So what we're going to start doing here is we are going to eventually, so today we're starting with Chromobugs. So this is kind of like the combination of the last week of everything we did. It's looking at Plunkett charts, complex heredity, looking at passing on 2 allele traits, predicting offspring, so on and so forth. So we're going to end up looking at Chromobugs here. So all the documents are available on the LMS. Now I've printed those off for you guys here. But there's a couple of them. So I'm just going to quickly kind of go through the instructions and we'll go through this together, but you're going to make a couple of these. These are what we kind of call Chromobugs. You guys can kind of see they're made of a couple of things, pins, and a couple of marshmallows. I have some toothpicks and I also have some pipe cleaner as well. So these are the types of things you're going to be making. I did have some examples to show you, but they kind of got thrown away by someone. So I don't have them now. So I will make one with you. But so you have a couple sheets of paper there in front of you, and I'll go through all of them here. But basically, what we're kind of looking at here is this is kind of a more practical thing. Now, obviously, it's not really ethical for us to like breed dogs for an experiment. This is kind of like mentally, be a substitute of that. This is the type of stuff that usually like people, specifically animal breeders, do. So we're looking at how these genes are passed from parent to offspring, and we're going to be looking at, again, the phenotypes, the genotypes, recessive dominant, blended dominance. If you remember blended dominance, well, I'll get to that later. But I kind of created Chromobugs as this nice way of combining all that. Basically, you're going to create a parent, you're going to breed the parent, and then you're going to look at what's the possible kids you're going to get. Here. So there's a couple of important things here that I recommend you guys probably want to underline or something or circle. So there's a couple facts. One of them is these are going to eventually have legs. The colored legs are dominant. The other one that you could have is you could have transparent legs, which I'll show you in a second. So again, dominant, of course, means if it carries a single dominant gene, then that means it's going to have the colored legs. But if it has a double recessive, it's going to have clear legs. Nose color, however, is blended dominance. The nose color will be blended. So basically, a hybrid genotype is going to produce a new colored nose. So if I say, hey, I'm going to say N for nose. If it's double dominant, it's red. If it's double recessive, it's yellow. But if I combine them, it makes orange. This is that red plus white equals pink thing. So blended dominance is red plus white is pink. You blend the two colors together, you get a new color out of it. So what's going to eventually happen, don't do this yet, but what's going to happen is you're going to select the traits of it, but you're not going to actually pick it. You're going to leave it to chance. You're going to flip a coin or roll a dice or something to be able to choose that. So you're going to pick like what's happening here with all these genotypes. So like, let's say, for example, you roll it, you get a heads and a tails. You would be a heterozygous. You'd be this one, for example. And so you're going to keep doing that all the way throughout this until you've picked a trait for all of these different parts. 7, just like Mendel, right? 7 things. So you're going to pick 7 things, and this changes what it's going to look like. It's going to have 2 marshmallows, 3 marshmallows. What's the colors going to be? Is the tail going to be curly or straight? Are the eyes? How many eyes is it going to have? Are the legs going to be colored or clear, etc.? So you're going to use a coin to do that. I don't actually have coins. I forgot them. I'm sorry, but you guys can just like flip a coin on your phone. Literally, Google flip a coin; it'll do it for you. So you're going to create a So you're going to create a father one and a mother one. And then what's going to happen is you're going to create a baby out of it. So you're going to create a mother and a father. You're going to quote unquote mate them, and then we're going to get an offspring from that. And you're going to look at what the offspring is going to look like. You're going to create the offspring. You're going to know its genotypes. Then what you're going to do is you're going to pick another mate for it. And that could be someone else's in the class. I'm also going to make one that you guys are welcome to use as well. You're going to pick a mate for that. For those of you online, I will upload those details here shortly so you have that. You're going to mate with those two parents. You're going to figure out the genotypes of it, and you're going to create a Plunkett square to show all the different possible traits. Sorry, all the different possible outcomes, but only for 3 traits. There's 7 traits. That's a lot of work. You're only doing it for 3. I think let's drink some water here. So basically, long story short, you're making a mother, you're making a father, you're breeding it, you're gonna create a baby, and you're gonna breed that baby. So we're doing 2 generations: parent, Gen 1, Gen 2. But technically 3 generations. So where you can keep track of a lot of this stuff. This is the dihybrid Plunkett square. This is for your Gen 2 stuff here. This is when that's going to happen. This could be how you can take, this is how you can keep track of what yours are going to look like. So for example, you would have, maybe the father, the mother, and the baby here, for example. This one? And this is where you're actually going to keep track of your the breeding of it. And specifically, what is it going to look like when you breed the 2 of them? When you breed the mother and the father, you're looking at what is it going to look like. So what we're gonna do is we're gonna start making those together ourselves here. Now, you guys have your paper. What I'm gonna recommend you kind of do here is you're gonna do this stuff here. So we're gonna do this, and you're going to specifically keep track of that on here. So you need both of these sheets of paper. Okay. So once you guys have it, I know it's hard to see on the screen. I apologize. Nothing I can really do there. I'm limited by how much space I have. So what's going to happen is you guys are going to make a father and a mother one. And so you're going to keep track of that on here. So let's say if you start with the father one, you would flip a coin to establish what the antenna is going to be, for example. So so maybe you're like, I'm going to make heads as dominant and tails as recessive, for example. So if I go to flip a coin, I'm going to flip it twice. So I said heads dominant, tails as recessive. So I have 1 dominant gene, and I have 2 dominant genes. So it would be double dominant. It would be AA, for example. Oh, sorry. It would be AA, which means that there'd be 2 of them. So I would have 2 antennas, for example. So I'd just like write that there. And then I would repeat the process for the legs, then I'd repeat it for the eyes, and so on and so forth. So I would do that for the father, and then I would do another one for the mother. And then you guys are going to actually make those. I have the supplies there to be able to do that. And then once you're done with that, I'll start talking about some of the next steps here, but I'll give you guys some time for that. Zoom recording, start video. So I just kind of finished up my first one here. Oh. So So this is here one example. So I have 2 body spots. I have my 2 antennae. I have colored legs there. You can see I have two of those humps, and I have a curved tail. So those are the phenotypes that I roll for this. This is the father. Now I would make another one as well, and then we're just going to breed them. And then we're going to breed them once. We don't even make one for every single one, but let's make the father and the mother. because that's really helpful as you go through this. Second one. Okay, so what's going to happen next is, so once you, oh, sorry, let me put my stuff here. So once you have created your parents, I'm just going to quickly put my stuff here. The legs I had. They were both colored. Just put in my stuff in here. The eyes I had this, so I had 2 on each. Pumps I had 2. Heterozygous. Pale, both were curly. PT. T. I forgot to put the noses on mine. No. Yeah, I'll do that in a second. It doesn't matter. And in body segments, I had I had double. Oh, so this is what I ended up having here for my 2. So now, so what I've done now, I've created a parent generation. Now what I want to do is I want to breed them, and then I just want to pick by chance which of the offspring I'm going to do. So for example, if I'm looking at this, if I know that, in fact, I want to be able to, I want to do this. I want to be able to draw on it. So if I'm breeding this, I know that I only have 4 possible outcomes between these things, right? And in this case, it's all going to be dominant. So no matter what I do, I'm going to have to pick double dominant here. Same thing for these recessive ones, right? These are both homozygous. So no matter what I do, I'm going to be recessive here. I'm going to have 2, and I'm going to have color. Where it gets interesting, though, is when I have some genetic variation. If I input this one here, for example, now it depends, like now what it's going to look like depends on it, right? So I would just pick, again, you could roll a dice between 1 and 4. Google will be able to do that. Let's say, for example, though, it picks the third one, it picks this one here. That's the one I'm going to run with. And I'm going to do that for all of these until eventually, I'm just going to pick some random traits here. Let's pretend I did it. I'm going to have a whole bunch of new traits that I'm going to pass on to my offspring. The reason I'm picking this by chance is because you can have different offspring off this. We know this, depending on which genes get picked. So what I would do now is I would take all of these traits and I would now put them just on here. So I would just make sure that, was it there? Not this one. Yes, it is that one. So I would put all those traits here. So for example, I think I decided that it was going to be, that my genotype here was double dominant, for example, right? So I'm just going through and I'm just listing out all possible genotypes. Then you're going to make your baby and you're going to breed it with another chromobug. And you can either use the 2 that I have there, you can use someone else's in the classes, that's fine. And I'll get to that next step. So the next step here is really, you're breeding your 2 and you're going to establish what are the possible traits that are going to get passed on to that. And then you're going to construct that baby, and that's the last one you'll build. Okay, so once you have gotten a baby, what you need to do now is the last little part here is you're going to pick any other Chromobug in the room. Now, for those of you online, I have my Chromobugs here. I've kind of listed, I've listed my baby here. I've listed all the traits of it. I'll just kind of scroll that down. I'll upload this document as well, but you can see my genotypes and my phenotypes here. For example, I can see I have a heterozygous here. I have a dominant and recessive, and I also have an orange nose as an example, is what my baby would have. These are just what I had picked. So now you're going to breed that with your own baby, and you're now going to predict the outcomes of it. And you're going to use this thing for it. So what you're going to do is you're going to pick a couple traits. So you're going to fill out 3 of these. And you're going to breed yours and the whichever mate that you picked. So for example, let's say if I picked mine, maybe I just want to look at antenna and legs. You know, that would be something like this. So if I were to put that in here, you know, imagine I'm writing this up top, you know, I'll just do it. Insert. So again, all the combinations of this case, in this case, would be AI, would be heterozygous. And then if I pick a mate, you know, if I imagine, then I just fill it out. And I just want to know what are the 16 outcomes that could emerge from this. Let's pick a little bit one. Let's pick one that's a little bit easy or a little bit harder here. Less straightforward. If I pick, here we go. If I pick these 2, for example, 2 recessives and then a heterozygous. That would be, what did I say? That would be too many documents open. Oh my gosh. Look at that. Okay, here we go. NNSS. Perfect. So if this is the case, I could have that, and I could have double recessives as well. So you're just taking your mates, whichever 2 traits you want, you're combining them, and then you're going to mate it with any other chromobug. You're going to figure out what their genotype is, and someone can just tell you. That's why I put I have that document up there if you want to use mine. You're going to bring it together, and then, for example, you might be, oh, I would get something like this. So you're just going through and you're listing out all the possible options, and at the end of this, you should have a total of 3 charts printed out. And then you're going to go to the genotype ratios. So let's say, for example, I have, you know, maybe I'll have 8 ones with red noses, for example. And maybe I would have, 8 red noses and 8 red noses with 2 segments. Maybe I have 1 orange nose with, you know, 3 segments, etc. So you're just showing, that's for the phenotypic ratios. For the genotypic ratios, you might say I have, you know, 8 and 2 dominant N's and 2 recessive S's, for example, and 1 of this, and so on and so forth. So you should be doing that a total of 3 times there. If you want to use mine, that's fine. I'll upload that document. I'll put it up on the screen here as well. But if you want to use someone else's, that's fine. You'll just need to get their genotypes from them.